Okay, extraneous solution is a solution that doesn't actually solve the original equation. It sometimes comes out in the algebraic process, but doesn't actually follow through with the original. For example, if I were solving a basic equation like this, and I happen to get a possible answer as x equals 0, well, 0 would not actually work because it makes the bottom of the fraction 0. So it doesn't solve the original equation, even if we were to actually get it as a solution when we're solving the equation algebraically. Now, over the next couple of examples, we're going to be solving rational equations, which are equations with fractions. And in Algebra 1, you may have done it with cross multiplication. And while cross multiplication will still work in some cases, it's not always recommended for Algebra 2 because it may increase the degree and add to the number of extraneous solutions. So we're going to take a different approach to dealing with the common denominator for all of the examples following this. Okay, so in this example, we're asked what is the solution of the rational equation 1 over the sum of x and 4 is equal to 2. Now, if I want to go through and do this, one approach to doing this is simply to find the common denominator between both fractions or all the fractions. In this case, our common denominator needs to consist of x plus 4, the factor from the one fraction, and 1, the factor from the denominator of the other fraction, which we don't actually have to include. So our common denominator is simply just x plus 4. Now that we have the common denominator, what we're going to do is we are going to multiply both sides of the equation by that common denominator. So our common denominator is x plus 4, so I'll multiply both sides by x plus 4. And on the left side, since I have one x plus 4 on top and one x plus 4 on the bottom of the fractions, they will end up canceling out, leaving me with 1. On the right side, I can't actually cancel anything out, so I have 2 times x plus 4. Now it's just a matter of distributing and solving this like a normal equation. So we'll distribute the 2 through, so we have 2x plus 8 equals 1, and it's a two-step, so we will subtract 8 from both sides and get negative 7 equals 2x, and divide by 2 on both sides, give me x equals negative 7 halves. Now, anytime we're doing rational equations, we do want to make sure that it doesn't make any of the original denominators 0. That would mean it's an extraneous solution because it can't actually be substituted in for x. So if we go and check to see if it makes the original bottom 0, so if we take our x value, which is negative 7 halves plus 4, negative 7 halves plus 4 is not 0. In fact, it is 1 half. And just double checking, 1 over 1 half, keep change flip, we would end up with 2. So it does work out. But the main thing we want to check is that it doesn't make the denominator 0. If it makes the denominator 0, then it doesn't actually work in the original equation. So negative 7 halves should be it. Okay, we are asked what is the solution for this equation. We have the sum of x and 3 over the difference of x squared minus 4, and that's equal to 1 over the sum of x and 2. So in order to do this, we're going to go ahead and find the common denominator again. We may be able to do it with cross multiplication, but that might introduce some extraneous solutions and raise the degree too much. So let's find our common denominator. In order to do that, we need to make sure the denominators are factored. X squared minus 4 is not factored. X squared minus 4's factors are x plus 2 and x minus 2. For our common denominator, we need each factor we see to the highest power we see in a single fraction. So I see x plus 2. I also see x minus 2. Neither one needs exponents. Next, we need to multiply both sides of our equation by this common denominator. So I'm going to multiply the left side. Actually, I think I'm going to rewrite it first. Okay, rewritten with the factored form on the denominator. Okay, so we're going to multiply both sides by our common denominator, which is x plus 2, x minus 2. In doing so, this should get rid of all fractions. X plus 2's on the first one cancels out, and x minus 2's also cancel out, leaving me with x plus 3. If there was indeed something still connected by multiplication, remember that since there's two terms, we need it in parentheses. There isn't, so we don't have to worry about that. X plus 2's on the right side will cancel out, leaving me with just 1 times x minus 2. In other words, we really just have x minus 2. Now we just have to solve this equation, so we're going to have to move all the x's to one side, since this is linear without any exponents. So we'll subtract x from both sides, which is going to cancel out, leaving me with 3 equals negative 2. Since the variable canceled out, that means one of two things is the answer, either infinitely many solutions or there is no solution. So since this is a false statement, since what we have left is false, then the answer is, well, there just is no answer. Okay, in this rational equation, we have 3 fractions. 1, 2, 3 through rational expressions. So when we solve this, we're going to take the same approach as what we had before, multiplying everything by our common denominator. So first, we're going to have to factor our denominators. X minus 5 and x plus 3 are already factored. However, x squared minus 8x plus 15 will need to be factored. There's no common monomial in all the terms, so I will multiply first and last. Give me 15x squared. The combination that's going to add to be our middle term is negative 3 and negative 5. So the factors overall are going to be x minus 3 and x minus 5. A lot of the times in Algebra 2, the factors will occur in one, if not multiple, of the other fractions. That's not always the case, so don't just assume that will happen. Make sure to check, but it does happen quite often. So if you don't get the same factors, you may want to just double check things. Okay, so now that we have it factored, the denominators, we're going to find our common denominator. The common denominator needs to consist of each factor we see to the highest power we see it in any one fraction. We see 2 factors. We see x minus 3. Highest power is 1 in a single fraction. And we also see x minus 5. Highest power being 1 in any single fraction. Since we have our common denominator, we're going to multiply both sides by that common denominator. So I'm going to multiply the right side by x minus 3 and x minus 5. However, since there are 2 separate fractions connected by addition, on the left side, we end up having to distribute what we're multiplying by through both fractions. So I'm just going to multiply each one here individually. X minus 3 times x minus 5 and x minus 3 times x minus 5, distributing it to both fractions, and then proceeding to cancel the x minus 5's, leaving us with 1 times x minus 3, canceling the x minus 3's, leaving us with plus x times x minus 5, and in the fraction on the right side of the equal sign, the x minus 3's cancel, and the x minus 5's, leaving us just with that 2. I see that we have parentheses, so in order to actually solve this now, we are going to have to distribute and combine like terms, and then determine if it's linear or quadratic. So distribute, get x minus 3, and distribute the x through, we have x squared minus 5x. My equals 2 comes down. I do see that it's a quadratic, so I'm going to approach this as I'm solving a quadratic. So let's combine like terms. So we have x squared minus 4x minus 3 equals 2. Again, it's a quadratic, so I'm going to move everything to one side. Let's subtract 2 on both sides and get x squared minus 4x minus 5. I do need to factor this equal to 0. I could either try factoring or quadratic formula. I'd prefer to factor it if it's factorable, so that's what I'm going to try here. I'll multiply first and last. giving me negative 5x squared. Combinations that add up to be negative 4 are negative 5 and 1. There's no leading coefficient, so I can jump straight to the factors of x minus 5 and x plus 1. Since it's factored, zero product property says if we have two expressions multiplied together to equal 0, then we just set each one individually equal to 0 and solve. So we'll add 5 to both sides, giving us one possible answer is x equals 5. And subtract 1 from both sides, giving us the second possible answer is negative 1. Now remember that this is a rational function. We still need to double check to make sure there's not any extraneous solutions. And the best way to check that is just to see if either of these will make the bottom of the fraction 0. So let's go ahead and double check. If we check the bottom of this first fraction, replacing x with 5, 5 minus 5 is 0, which means this 5 is an extraneous solution. While it does come out algebraically correct, it does not actually solve the original equation. Essentially, when we turned it into a quadratic rather than an irrational, we added an extra solution. For the negative 1, if I try that one, going with the same denominator, negative 1 minus 5, that's not 0, so we're good. Same thing with the next one, negative 1 minus 3. Not 0, that's all I really care about. And if you plug it into the third one, you would find the same thing because the factored form is over there and it doesn't make either of the factors 0. So negative 1 does work as the answer. So in this one we have once again 3 fractions for this rational equation. So as I go to solve this, I am going to first find the common denominator. All of my denominators happen to be already factored. 7 as a fraction is 7 over 1, and x minus 2 can't be factored. So our common denominator needs to consist of the x minus 2 that I see. And since 1 multiplying by 1 won't change anything, so our common denominator just needs to be x minus 2. I need to multiply now each fraction by x minus 2. On the left side, I'll just multiply like normal. But on the right side, because there's 2 fractions, I'll have to distribute it through to both fractions. And here's what we have after distributing it through. So if I cancel things out, that should eliminate all fractions. X minus 2 is here, will cancel. So we have 5x equals 7 times x minus 2 plus 10. Once you get rid of the fractions, you just simplify doing distribution and then solve it like a linear or a quadratic depending on the situation. So we'll distribute the 7 through. Give me 7x minus 14 plus 10 and combine like terms. So we have 5x equals 7x minus 4. Now this one happens to be a linear equation. There are no exponents, so I'm going to move all the x's to one side by subtracting 7x. So negative 2x equals negative 4. And then I just have to solve for x, and I'll do that by dividing by negative 2. So we have x equals positive 2. Now this is a rational equation, so we do have to go back and check the factors, make sure it doesn't make any of the denominators 0, because that is a big issue. If I go back up here into the x minus 2, and I replace x with the 2 we found as our solution, having 2 minus 2, 2 minus 2 is 0, which causes a problem. That means that this 2 cannot be a solution. It's extraneous. While algebraically we didn't have any mistakes, it doesn't actually solve the original equation. That's what extraneous means. And since we have no other viable options for solutions, there just is no solution for this equation.